right, so let's take a look at these questions. A merry-go-round at a playground has a radius of 6 feet, and it takes 10 seconds to make a full turn. What is the linear speed for the children riding this merry-go-round? Hold on just a second. Let me get my pen attached. There we go. Okay, and we're assuming these children are sitting on the outer edge of the merry-go-round and not in the very center, because that would change our answer. We are asked for linear speed, and we are given the radius in feet and the time in seconds to make a full turn. All right, so for linear speed, how do we find linear speed? Our velocity. Linear velocity, we can either find it using S over T, the distance traveled divided by the amount of time it's traveled, or with our given information, we can take the angular speed or angular velocity times the radius, and we've shown that these are pretty much the same thing. It just depends on what information you're given. Okay, so let's see what we're given. Are we given the distance traveled? No. Are we given a time? We are. But notice the time we're given is the time it takes to make a full turn and not necessarily a linear distance, which is angular velocity. Okay, so angular velocity, remember, we find that by taking our angle divided by the amount of time it takes to make that rotation. Well, a full turn is once around the circle, right? And so what is the angle for going all the way around the circle once? That angle is 2 pi. So we've made a rotation or an angular distance of 2 pi. We divide that by the amount of time it takes to travel, and that was done in 10 seconds to make one full turn. Okay, so I could just reduce this fraction, or you can find the decimal number that goes here. Reducing the fraction helps because it keeps me on with my exact answer and not a rounded answer. The more you round at the beginning, the further you get from the exact answer at the end. That's just safer that way. But you could use a decimal here and take 2 pi divided by 10. All right, so we have our angular speed. It's pi over 5 radians per second. Okay, remember our angle was in radians, our time was in seconds. We can use that now to find our linear speed. It's the angular speed or velocity, which we found to be pi over 5 radians per second, times the radius of our circle. It says that the radius of our merry-go-round was 6 feet. Okay, so all we have to do now is calculate pi over 5 radians per second. So pi divided by 5, and then times 6 feet, and we get a speed of 3.77 approximately feet per second. Okay, that would be the speed of the children traveling on the edge of that merry-go-round. Okay, this next one is similar. We're dealing with a merry-go-round, but this time they ask us to find the angular speed and the linear speed. Okay, we have a merry-go-round with a 14-foot diameter. Now that's something you want to keep an eye out for, because diameter, remembers, all the way across the circle, and with most of these formulas we use the radius. Okay, so right now I'm just going to go ahead and say 14-foot diameter means I have a 7-foot radius, just in case that's an issue later. It makes 10 revolutions per minute. Okay, 10 revolutions per minute. The first thing they want me to find is the angular speed of the merry-go-round in radians per minute. Right now it's in revolutions per minute. Well, how do we find our angular speed? Remember, once again, it's our angle in radians divided by the amount of time. Well, how many radians have we traveled? Remember, 10 revolutions means 10 times around the circle. Okay, so once around the circle is 2 pi, so 10 revolutions, 10 times 2 would be 20 pi. That is the measure of our angle. So we know our angle is 20 pi. The amount of time to travel that distance, how long did it take? 1 minute. And they want our answer in radians per minute. So we know we traveled 20 pi radians in 1 minute. And if we divide 20 pi by 1, we get 20 pi. So our angular speed or angular velocity is 20 pi radians per minute. And we solved part A. Part B wants us to find the linear speed in feet per minute, okay, for the rim of the merry-go-round. Well, we know that we find our linear speed by taking angular speed times the radius, okay? Our angular speed was 20 pi radians per minute. The radius of our circle in feet, which is important to check, it did want it in feet and we had it in feet, which is nice. The diameter was 14, which if we divide that in half tells us we have a radius of 7. So we have 20 pi radians per minute times 7 feet. That gives me 140 pi feet per minute. Okay, and if you want the decimal number for those, you can just calculate with your calculator, but exact answers a lot of times are better than rounded answers. All right, so we found it, angular speed and linear speed. Which brings us to our last question. Here we go. A 6.5-inch circular saw blade rotates at 1,325 revolutions per minute. They want us to find the angular speed in radians per minute and the linear speed in feet per minute of one of the 24 cutting teeth. Now, really, it doesn't matter how many cutting teeth are on our saw blade. This is kind of an irrelevant piece of information because any point on the edge of the blade is going to be traveling at the same speed, no matter how many teeth there are, okay? So we need to concentrate on information we need to find the angular speed, okay? Again, angular speed is our angle divided by the amount of time. This says that the blade rotates 1,325 revolutions per minute, and we want that in radians per minute. Well, once again, a revolution is once around the circle. That would be 2 pi radians. So we are doing that 1,325 times. So if we take 1,325 times our 2 pi, we get 2,650 pi. And I'm going to leave the pi there because, once again, exact answers come out better than rounded answers, okay? And this is in radians per minute because that was in 1 minute, okay? If they had said in 3 minutes or 4 minutes, we would have to do some division there, but our time was 1, so it just comes out. Next, they want the linear speed of a tooth on the edge of that saw blade. Okay, once again, we know linear speed is our angular speed times the radius of our circle. Now, one part that's important to note is that when they give you the size of a saw blade, this number is the diameter of the saw blade, okay, not the radius when they measure those. So our diameter is 6.5. We need the radius, okay, so we take 6.5, divide it by 2, and we get 3.25, okay? And what was that in? That was in inches. Now that's important because when we look at our answer, the request for our answer, they want us to find the linear speed in feet per minute. So using inches is not going to work here. So now that we have our radius of 3.25 inches, we need to convert that to feet. Well, how many inches, excuse me, are in a foot? There are 12. So 3.25 inches is 3.25 twelfths of a foot. I'm going to divide that and I get 0.27083. And this is one of those. I'm going to go ahead and round. Okay, so for our radius, we had to take the diameter of the saw blade and cut it in half. And then since we were in inches but wanted an answer in feet, we had to convert from inches to feet. So we have 0.27083 feet for a radius. And we just bring it down here. Our angular speed was 2,650 pi radians per minute. And we are going to multiply that by 0.27083 feet, the radius of our circle. I'm going to go ahead and multiply out the pi, so 2,650 times pi times 0.27083, and I get 2,254.72. And what was that? That was our speed in feet per minute. So that is how fast this saw blade is traveling, 2,254.72 feet per minute.